And with us today is an astronomer from Toronto, Ray Jayawardena. He's a professor of astronomy and astrophysics at the University of Toronto, and he has an exciting new book talking about the search for extrasolar planets called Strange New Worlds. And we're going to talk about the recent developments, the discovery of over 500 planets in outer space orbiting other star systems, the Kepler telescope, and the possibility of extraterrestrial civilizations in outer space. And if they're out there, then how come they don't visit us? How come they don't land on the White House lawn announcing their presence? Well, once again, the book today is called Strange New Worlds, written by Ray Jayawardena, professor of astronomy and astrophysics at the University of Toronto. Well, Ray, let me ask you a question that I always ask scientists, and that is, when you were a child, was there one thing that set you off on this grand journey to discover the universe? Was it a telescope, a chemistry kit, a visit to the planetarium? What set you off in this direction?
Hi, Michio. Good to be talking to you. The earliest memory I have is actually my dad telling me while we were walking in our garden in Sri Lanka, which is where I grew up, pointing to the moon and telling me that people had walked on it. And I remember feeling that, that was astonishing. The idea that you could walk on something in the sky truly boggled my mind. And that's the earliest memory I have of being interested in space. And obviously it was the sense of adventure, the possibility of adventure that excited me as a child, much more than the science itself. But that planted a seed that grew into, over time, into interest in astronomy and space.
And when you were in high school, did you have a telescope to look at the heavens?
I didn't myself, actually, but friends of mine did. I was a member of an amateur astronomy group called the Young Astronomers Association, and I read a lot of books about astronomy and space, and I met Arthur C. Clarke, the famed science fiction writer who lived in Sri Lanka. So that all of those influences contributed to my interest.
Okay, well, your book is called Strange New Worlds, about the discovery of extrasolar planets. First of all, most of us learned there were 9 planets in the solar system, but Pluto got kicked out recently, so there are 8 planets in the solar system. But now what you're trying to tell me is that there are literally hundreds of planets orbiting other star systems, right?
Absolutely. So it's truly been a revolutionary time in this field. After centuries of speculating about worlds orbiting other stars, in the last 15 years, astronomers have compelling evidence of planets orbiting other stars, at least 500 of them. So that's been a sea change in our understanding and has really changed our perspectives of how our own solar system stacks up against all the others. And some of these worlds that we're discovering are quite different from ours or anything in our solar system. So our views have really dramatically expanded, and we're discovering an incredible diversity of planets out there. And there's a whole series of techniques that have succeeded, many of them indirect to begin with, like measuring a wobble of a star to infer the presence of an unseen planet, or to see the periodic dimming of a star when a planet passes in front. But more recently, my own team was involved just 3 years ago in taking the first picture of a planet orbiting another star. That's quite remarkable, to be able to point to a little dot next to a bright star in our picture and to be able to tell you that that's a planet orbiting that star. So we've come a long way in short 15 years.
And planets do not give off light of their own. They give off reflected light. And as a consequence, they're, about 1 billion times less luminous than the mother star. So it's no trivial task, right, to find these tiny little dots that are basically black orbiting other stars.
That's indeed the case, at least for mature planets like the planets in our own solar system. Even Jupiter, the most massive planet we have here, is nearly 1 billion times fainter than the sun in optical light as seen from a distance. But when planets like Jupiter are young, they actually do produce their own heat, because they're still in the process of formation, they're still contracting, shrinking in size, and in the process they convert gravitational energy into heat. So they're a lot brighter, hotter and brighter when they're young than when they would be as a mature planet. So the kind of planet that we took a picture of is only about maybe 10,000 times fainter than the star, rather than being almost 1 billion times fainter. And that gave us a big advantage to go after young planets, young newborn worlds orbiting young suns.
Now, the first thing that people think about when they hear about extrasolar planets is, are any of them like us? How many of these 500 or so extrasolar planets have any resemblance to the planet Earth?
Well, the majority of them are rather massive, but we're getting much closer to being able to discover planets much closer in size to ours and in orbits like ours. So just a few of the worlds that have been discovered in the previous 15 years are what we call super-Earths, planets that are only a few times more massive than the Earth, only maybe 10, 20, 30% bigger in size. But now, with the Kepler Space Telescope, which NASA launched 2 years ago, astronomers have for the first time the capability to discover roughly Earth-sized worlds by the dozens. So that's an interesting milestone that we, for the first time now, have that ability. And in the first year of data that Kepler satellite gathered, and those results were announced just a couple of months ago, there are a few dozen roughly Earth-sized worlds. Now, almost none of them are in the right sort of, at the right sort of distance from their stars to have the liquid water, which we think is essential for life. So if we're in the hunt for life elsewhere, then we'd have to wait a little longer, but we're quite confident that within the next couple of years, Kepler will reveal not only dozens of other roughly Earth-sized planets in Earth-like orbits around other suns, but also that we'll have a good idea of how common such worlds are.
Now, when I was in school learning about the solar system, we learned that our solar system was probably average, that there were planets in circular orbits around the star, that Jupiter was far away in a stable orbit so that it wouldn't barrel into the Earth and destroy the Earth. But now we realize that we're the oddball, right? I mean, absolutely none of these extrasolar solar systems look like our solar system with these nice little neat orbits and Jupiter in a very stable orbit around the sun, right?
Indeed. So that really has been an incredible change of our perspective. We used to think if you only knew about the one planetary system that we live in, we had a very limited view. But now we've discovered such a diversity of not only worlds, but also different architectures of planetary systems. Somewhere, there are so-called hot Jupiters, Jupiter-like worlds basking in the heat of their stars, orbiting them every few days instead of every 12 years like our Jupiter does. So planets not where we expected them to be, or very different kinds of worlds, these super-Earths, perhaps rocky worlds bigger than the Earth that we don't have in our own solar system, some planets that have incredible differences in their day and night side temperatures. So quite a variety out there. Now, to be honestly answering the question whether our solar system is typical or not, we're not quite there yet because of the biases of our techniques so far, that it's been easier to find more massive planets that are closer to their stars. So we don't really know whether our solar system is typical or not. We do know that there are many others that look rather different, that are not anything like ours. So in that sense, our views have changed, and also it shed new light on the early days of planetary systems. Looking at our own, we used to think of the solar system as being rather quiescent, but now looking at these other worlds and other planetary systems, it looks like the early days of soon after their origin may have been rather dynamic or perhaps even chaotic, with planets moving around, migrating inward. Some of them perhaps even be kicked out of the planetary system through kind of slingshot games played by gravity. All kinds of activity, all kinds of action going on that we didn't expect to have happened in our solar system, at least the way we knew it 20 years ago.
Now, if our solar system were average, it would mean that the probability of life in the universe would be relatively high because we're a very typical solar system. And there are equations like the Drake equation that try to do that estimate. However, if our solar system is really kind of an oddball, and that most solar systems fling their Earth-like planet into outer space because they're unstable, then perhaps our solar system is quite rare, in which case life could be rarer than we thought. So has that resulted in a change in astronomers' attitude toward life, that perhaps the conditions of life are really quite stringent, and perhaps our solar system is an oddball, and therefore life is more difficult to find in the universe? What are your thoughts?
Well, for now, we're still keeping an open mind. But as I said, within the next couple of years, as the Kepler Space Telescope really starts to tell us the statistics of different kinds of planetary systems that are out there and tell us how common or rare roughly Earth-like planets are out there, then we will know the answer to that question. In the sense, we won't have direct evidence of life, but at least we'll be able to tell you how common are other habitable worlds like ours, around other suns. So by monitoring some 150,000 stars in one little patch of the sky in our own galaxy, Kepler for the first time will give us good statistics of to answer that big question. And so it'll be a very interesting answer to have as we do want to get closer to being able to answer the big question of life elsewhere.
Okay, let's take a short commercial break. Once again, the number to call is 866-323-2538. You're listening to Science Fantastic with Professor Michio Kaku, and the book is called Strange New Worlds. So give us a call. This is Science Fantastic.